Good day, I am Monica Faye Del Rosario Herrera, ISCS 11, and this is my tutorial on how to execute round robin or what we call RR. I'm here to discuss about round robin or RR. First is we need to define the round robin or RR. It is defined as the process are dispatched in FIFO, which means fast in and fast out manner. But the processes are given a limited amount of time and these processes that are limited amount of time is called as quantum time or time slice. We need to understand that this quantum time is the time that is assigned to each processes. Yeah. The meaning of this quantum time is the time that is assigned to each process, and it's often called fixer time that is allocated to each process to execute, which means quantum time is our basis to our process. And another thing is if a process does not complete before its CPU time expires, the CPU is preempted and given a chance to next process what is waiting in queue. So, next is if the process does not complete before its CPU time expires, the CPU is preempted and given a chance to next process what is waiting in queue. And round robin is like this. So this is how it will be executed in our computers. So next is I will give you examples of how this round robin will be processed and executed in our CPU. First is example our RR or round robin with time quantum. We will have the value of 20. So, we need this process which represents as P1, process 1, P2, P3, and P4 as process 1, 2, 3, and 4. And we need our burst time. Um, 53, 17, 68, and 24 for P4. And first thing we need to do is select which we need to write our P1 because this is the first process and our starting value is always 0 and our limited time is 20. For our P1, we have 53, but our limited time is only 20. So, we need to minus our P1 to our quantum time, which is 53 minus 20 is equals to 33. And our first value in P1 is 20. Second is P2. Our value in P2 is 17 and our time quantum is 20. So, we don't need to minus 17 into 20 because our round robin can process 17 because time quantum is greater. So, we will write P2 plus our value of P2 which is 17. So, 20 plus 17 is equal to 37. Next is our P3. So, 68 minus 20 is equals to 48. These numbers are called limited burst time. So, 37 plus 20 from our P3 is 57. So, here is our P4. So 24 is greater than 20. So, we need to minus it like 24 minus 20 is equals to 4. Which is, so in P4, our limited burst time is only 4. So, we need to add that. 57 plus 20 is equals to 77. So, we finish all the P1, P2, P3, and P4. So, we go back to P1. Siya. Round robin. Which means we need to go back to P4 to P1 till our limited burst time becomes 0. So, next is P1. We have 33. 33 minus 20, our quantum time, is equals to 13. So, our P1 is 77 plus 20 is equal to 97. Next is our P2. P2 is over, so we need to skip P2 because all of the burst time in P2 is we already executed. So, next is P3. We have 48. 48 minus 20 is equals to 28. So, 97 plus 20 is 117. And we go to P4. Since 20 is greater than 4, we need to just add 4. Like 117 plus 4 is equals to 121 for the value of P4. So, we already used the 4 and P4 is over like P2. So, we have P1, which is 13. 13 is less than 20, so the time quantum can execute 20. So, 121 plus 13 for the value of P1 is 134. P1, P2, and P4 is already over. So, we need to go to P3, which was the value of 28 minus 20 is equals to 8. 134 plus 20 is equals to 154. We still have the value of 8, so we write again the P3. 154 plus 8 is equals to 162. And so, P1, P2, P3, and P4 is all over. And this is how round robin or RR works. Thank you.